All right, I actually have there's a blue jay calling in the background here. I was just going to talk a little bit about why we're doing our survey as a distance survey, as I kind of go down the final stretch of the survey route here. So a complete survey of animals in the area would be a census. And we could have done a strip survey where I told you to count any bird that you see out to 50 meters, for example, okay? So that's a strip survey, and I would be assuming that you would be counting every bird out to 50 meters on both sides of our transect line. But we actually know that your detectability, through a lot of surveys and research, we know that your detectability of birds is not complete when we do these surveys. And so to account for biases that we might have, there's our blue jay, and another one off to my left. I got to remember where he is and mark that for later data here. To account for that potential bias, because blue jays, you could hear from a long ways away. They're pretty loud. But robins on this survey, I haven't heard any robins sing, but I've seen a lot of them on the ground. But of course I only see them out to like 10, 15 meters away at the most, because that's where people's yards are. So my detection of the robins is more limited. Doesn't mean there isn't robins past where I can see them. It's just that I can really only see robins up to about 15 meters if they're not singing. So we do these distance surveys because it uses an analysis method that will correct for these and will estimate the detectability of each species. In the lecture portion, if you take wildlife management techniques lecture portion at University of Nebraska, you'll learn how to do that analysis specifically. In this class, we're going to end up summarizing data and looking at patterns we see. And I'll show you my results here in just a second. But the general idea is that we assume that if a bird calls right above our head or right at our feet here, that I'm going to see it. And so it has 100% detectability on our transect line. So there's my transect line behind me, sidewalk I've been walking on. But we assume that detectability falls away as we go away from the transect line. And at some point out there, point that we don't know, that detectability will fall to zero. And so we're going to use the observations that we have to estimate for me, for Larkin, and you would have a slightly different estimation curve because you might have better ears than I do. You may have walked the trail at a different time. I just went past a lady vacuuming her car outside her house, and while I walked past that house, my detectability of birds was not very high because there was a lot of competing noise, right? And so there's a lot of reasons why detectability can vary. If somebody came out here not knowing, blue jay still calling behind me, if somebody came out here not knowing what that blue jay call was and just looked for visual observations of blue jays, I haven't actually seen any blue jays on this survey. But so far, if I include the two that are calling near me here, I'm up to 8 observations of blue jays so far. So if we relied just on visual confirmation, our detectability of blue jays would be pretty low as well. So that's some of the basics of why we're conducting a distance survey. And there's other methods that people use to account for detectability, but by not just collecting the observation, but by collecting this additional piece of information, which is the distance that we've seen away from us, we'll be able to build a detection curve. And you'll see those detection curves in the video that follows this.